Hey guys, welcome back. So this is third video as part of our ECS container series. All right, so in our previous two videos, in video one we discussed how to prepare image locally, and in video two we have discussed how to push that image to central repository. Now the third phase is like the third step is whatever the images we prepared here, so that we need to run inside ECS cluster, right? So, but before running it in ECS cluster, we need to prepare a task definition. So for that, go to Amazon ECS. In left pane, we have task definition. But before task definition, the cluster creation process is very, very easy. It's a very straightforward. Go to clusters, create cluster. What is the name of cluster you want to give? In what VPC you want to run? Right, what name you want to give? What are the infrastructure capacity provider method? Basically, we call it as a capacity providers. Okay, so the Fargate, the AWS managed one, and EC2, where AWS is going to run our workloads inside an EC2 instance. Right, so then external, we can install this ECS agent in our own hardware, in our data centers, then we can run. So here I'm going to talk about this AWS Fargate, then click on create. That's it, one cluster is going to create. Okay, but after cluster creation, how we can run this? Okay, so if I want to run this Nginx, I need to define some container properties, right? How many CPUs I want to define, how much memory I want to define to run this and all. So those all we first need to configure in the task definition. Okay, so when you go to task definition, it will show only active ones. Click on create new task definition, click on create new. Okay, so first I will go with this node app task definition. Okay, or node app, that's fine. So now what is launch type? I'm going with launch type as AWS Fargate, where underlying resources, the infra, is going to be completely managed by AWS. And OS architecture, you can go with any here. The Linux is a default one. We are good with the default one. And if you are running a task, one task is nothing but one Nginx or one node application now. So you can define. So I'm going with the zero point 0.5 CPU and 1 gigs of the RAM. So if you want to less than that, zero point 0.5 GB, a zero point 0.5 virtual CPU and a zero point 0.5 gigs also. So I'll good with this one CPU and 2 gigs of the RAM. Task sizes again, it depends on what application you're delivering, how critical that application you're delivering, what exactly workload you really require, the resource you really require. So you can define that here. And task role, so if you want to access any other services from this task or from that uh, application you're going to run, so you can create one and you can associate that here. The default one is easiest task execution role. So you can go with none, and task execution role you can pick, or you can initiate to create a new one. AWS will create one for us. So I already ran this multiple times. So this ECS task execution role already created. So I'm going to choose the same one now. And here, what is a container name? So the container name, I'm going to call this as node. My node is a name. And what is the image URI? So the image URI, once you push that image to this ECR, we are going to get a URI. So when you click on this, it will show the URI. You grab that URI and you give that here. And also for easy understanding purpose, you can give same name for this task definition as well. Okay, it's not mandatory, but for easy identification. Now, the port mapping. If your application running on port number 80, you can define that 80 here. For example, sometimes you may configure to your application ran on port number 3000 and all, you can define that here. So we are good with 80 that is running on HTTP app protocol. So then scroll down and you can enable logging if you really required, and you can configure storage and you can add volumes from EFS and all. So uh, I'm not interested much at moment. Then click on create. So now one task definition created for our node application, and let's create another one for Nginx. So the Nginx one, let's grab the image URI, copy URI is here. My Nginx, I want to run with AWS Fargate, one CPU, 2 gigs of the RAM, ECS task execution role. So my NGI NX and give the image URI. So then port number 80 it is also running on. So then scroll down, create. All right, I have two task definitions here, and I want to deploy these task definitions into our ECS cluster. So now go to clusters, click on create cluster. Okay, but before creating cluster, you need to verify your VPC settings also. So, do you want to run this cluster and load balancer everything in a default VPC where all subnets are public subnet? That is one option. If you don't want to run this in uh, default VPC, you want to secure at VPC level also, right? So you can create a custom VPC. Okay, so you ran your ECS cluster inside that VPC and you run your tasks or you run your service. Basically, the service is like, group of tasks. So the web servers or node application, if you want to run inside a private subnet, so it's recommended to go with the custom VPC instead of default VPC. So if you're very beginner, so you can start with this default VPC. But if you already have some experience with this VPC and all, what exactly public subnet, private subnet and all, so then I suggest you to go with the custom VPC where you have some public subnets and some private subnets. Okay, so for this demo, I'm going with default VPC. Okay, and the subnets, I'm going with all the three subnets, and it is the I'm going with the capacity provider as a AWS Fargate method. And if you want to enable container insights where CloudWatch will give graphs regarding CPU, memory, disk, and network usage of this container. Okay, if you want, you can just enable this, but it comes with additional cost. Click on create. Okay, the cluster name. My demo cluster is the name I'm giving. Then click on create. And also point to mention, I already made a video on VPC. Okay, so just take a minute and go through that VPC video if you don't know how to create some public subnets and private subnets. All right, so the demo cluster is creating. It won't take much time. So you can verify the progress. All right, I gave a quick refresh and the cluster status is active. So now once the cluster created, right, so what we can do, we can run individual tasks here. So if you just want only one task or for testing you want to run one task, you can do that here. And if you want to run services, like a service is nothing but combination of multiple tasks. Okay, so if you want to deliver multiple applications, so in my case, I have Node application and I have Nginx, right? I can create one service for Nginx that, run some task, and I can take another service for my node application where that also going to run some tasks. Okay, so but before configuring these tasks and services, so we need to pay attention towards to our security group. Whenever you are creating a task, okay, so it is going to ask us under networking, it will ask us what security group you want to use and all. And also, whenever you are creating a service, we have an option to integrate this with our load balancer as well. So if you want to integrate with load balancer and all, so obviously you need one security group for your ECS tasks or services and another security group for your load balancers and all. So first let's go to EC2 and let's create a couple of security groups. We need at least two. One is for load balancer, second one is for our tasks or the services. Whenever you are creating, we need to configure the network part. So there we are going to. Let's click on create security group. First, I'm going to create a security group for my elastic load balancer, ELB-SG, security group for ECS cluster, and add role. So this load balancer, I'm going to deliver traffic on port number 80 for everyone. And also we have multiple applications, right? One is Nginx, second one is Node. So I want to deliver another one on 8080. So I'm going to open 8080. At load balancer level, we're good to open for anywhere. Okay. So then click on create security group. So fine, this load balancer security group created and we need this security group ID. So then click on create security group and I'm going to call this as a ECS SG. Okay, security group for ECS network like components like tasks or services. Okay, so then inbound role. So here, based on your application, what your application is running on port number 80, 8080 or any other port, you can open that. But there is a one method I follow. So I'm going to open all traffic, but again, not to everyone. I'm going to open all traffic to my security group of my load balancer. So piping all traffic to ELB SG. Okay, so this method I personally follow. If you don't want to open all the traffic, so you can simply go and open up the rules and you can give security group, right? So as it is a piping, we are not opening for everyone, so we are good with the setting. So then scroll down, create security group. So now one security group created for ECS resources also. Now the load balancer one we will configure. So again for testing purpose, just for one-time testing purpose, I want to run one task for testing purpose that runs on HTTP port and I'm going to open it for my IP address, then save rules. Again, this entry is just for testing purpose, right? I'm going to run a task. So go to cluster, navigate to tasks, run a task. So now when you're running task, it will ask you what is a launch type. I'm going with launch type. Okay, instead of capacity provider strategy, like, minimum base, weight mechanisms and all. So let's go with the launch type. And launch type is Fargate. Let's go with the platform version as a latest. So then scroll down. And what family? The family is nothing but the task definition you already created and kept it ready. So at moment, I'm going to test with this my Nginx and it has only one version and how many tasks you required? One. And then network. In what VPC you want to run, what subnets you want to choose, and the security group. We created one security group and we kept it ready, right? So you select that ECS SG and I'm going to enable public IP address. Okay, the reason I just want to test output from my local laptop. So I have enabled public IP and I hope you might got the reason why I have opened HTTP for my network. I want to test this. Then click on create. All right, so now one task is running, and let's go and select the task. And here you can see the task status. It is in provisioning state, and now it is in pending state. Now it came to running state, and sometimes what happened, if there is any problem with the image you have prepared, so it is going to fail here. So I faced a issue. So right, so the reason, like the task definition, I went with the default option. So the and I prepared Docker images from my local laptop, where, as I mentioned, where I am using M1 chip. So that is going to pick some of such type of properties, and when I'm running this image, it is going to fail immediately. So that is the reason, like I took an EC2 instance, and I started explaining this thing. So now the task is in running state, and here is a public IP address. Grab the public IP address, give that here, and you see our Nginx page is delivering now with the help of public IP address. So our application point of view, we are good. So you can go and stop selected. If you want to test that node one also, you can run launch type as a Fargate. I'm going to run a task, and I'm going to select my node. I need one task, network. Make sure you select that ECS SG. If you want, you can keep the default or you can leave it, then create. You might get a doubt, okay, why Avinash is taking one Nginx and another one node? So there is a reason. We can use one cluster to run multiple services, and we can use one load balancers to deliver all these. So I want to demonstrate that. So that is the reason I am taking two applications. So here is a task. The task is in running state, and we got a public IP address. Let's grab that public IP and give that here. And you see here, we got the required output. So we're good with this part. So the tasks are running as expected. Okay, so now let me stop this task as well. Okay, right. So generally in our workloads, we are not going to run individual tasks. We are going to depend on services, and we are going to deliver. So whenever you're creating a service, it will ask us, do you want to use any load balancer and all? So yes. So whenever you are running multiple tasks, you should have a single point of contact for all the tasks, right? How end customer is going to point to each and every public IP address you are going to get for every container? No, right? So uh, instead of sharing that individual IP addresses, you create a load balancer, and whatever the task creating here, automatically we can add that to load balancer target group, and we can deliver via load balancer DNS name. So to achieve this, first go and create a load balancer. So let's navigate to EC2. Now in left pane, we have this load balancer option. Go to target groups. First create a target group. We can even create a load balancer while launching this, while creating the service also, but I prefer to go with this option. Click on create target group. Select target type as an IP address. Why? Because these are not instances to register. So we are going with IP address. It will register with IP address. Target group name ECS TG. Node is a name I'm giving, or let make it simple. Node hyphen ECS TG. Port number 80, and in what VPC it is going to run. Select the VPC. Health check you can perform on slash, then click on next. I'm not going to add any instances at moment. Then create target group. One target group created here. Then go to load balancer. then create load balancer. I'm going to create an application load balancer, then give load balancer name. I'm going to call this as ECS demo. I'm going with internet facing one, IPv4, and I'm going to select all the three subnets available in this region. Security group, we already created and kept ready. So I'm selecting that ELBSC. So now whatever the traffic coming on port number 80, the listener, I'm going to redirect to this node ECSTG, then scroll down, create load balancer. So now the load balancer created, and in backend we have a target group. That target group currently don't have any targets. All right, we are going to use this load balancer now with this ECS. All right, let's go to services, click on create, and capacity provider as a launch type Fargate. This time I'm going with service instead of task. What is a family? I want to run my node. The revision is version 1 only. Service name. So node app service. And how many tasks you required? I want two tasks. So do you want to enable service connect? Right. So you can enable this. So if you want to, like, you want to go and integrate with any of the applications and all, so that not really interested, go with networking. And here, go and select your security group you created for ECS. So public IP address, if you really want, you can enable. If you don't want, you can uncheck. The communication between your uh, Docker images, Docker containers, and the load balancer happen with the help of private IP address only. This purely your choice. Load balancing. Load balancing type, I'm going to use an application load balancer. If you want to create one, you can go and do that now. But we already created one and kept it ready, right? I'm going to use an existing load balancer. Then load balancer name. When you pick the load balancer name, it is going to choose the container to load balancer ports automatically. And listener, on my load balancer, I already have a listener. If you observe, we already have a listener. So I'm going to use this listener now. So use an existing listener, select one. And target group. Target group also, we already created and kept it ready, right? So I'm going to use an existing target group, select the target group now. So now what happened? Whatever the two tasks we are going to run for this task definition. Okay, those two tasks now go to this target group and it register as a target. As this target group is delivering or attached to load balancer, we will get output with the help of load balancer DNS name. That is what happened in backend. So now let's scroll down, create. So now the service creation started. You can even verify the status in cloud formation. Click on view in cloud formation. Okay, sometimes we may get errors. Okay, so if you want to identify what is causing that issue, to fix that issue, you can refer this cloud formation events and status reason. Now the ECS service creation is initiated. So all you need to do is wait for some time. Here, the service started and two tasks in pending state, and you can see two is in progress. Okay, and also if you observe this target group status, currently two target registration is happening and health status is initial. So automatically this target registration is happening with the private IP address and both are healthy at moment. So now how to test this? Go to your load balancer DNS name, grab the load balancer DNS name and give that here. And you can see we are getting output from that ECS. service. So the ECS service currently has two tasks, two tasks successfully deployed, and you can even go to tasks and you can verify what is a task, what is a public IP address, what is the status. You can verify that. So this is output for one task. So we can create another service and you can use existing load balancer only to deliver that. Okay, let's do that now. So click on create and capacity provider as a launch type. I'm going with service, my existing one on port number 80. Okay, I'm getting this output from my node application. This time I'm going to choose my Nginx service name. I'm going to call this as a Nginx. How many tasks you required? I need two tasks. So networking, I'm going with again the ECS SG. This time I'm going to choose again application load balancer. I'm going to choose an existing load balancer. New listener definitely required. So why? Because port number 80, we are already, so this port number 80, we are already using it for our existing application. So obviously you are not allowed to use duplicate port numbers. What you can do, you can create a new listener on 8080. So then I'm going to create a new target group. So Nginx TG -8080, I want to perform health check on slash. Then, right, if you want to perform service auto scaling, you can enable this. What is the minimum number of tasks you required, maximum number of tasks you required? So what is auto scaling group mechanism you want to use? Target tracking scaling mechanism or step scaling mechanism? So, like, the AWS will automatically, based on the load, it automatically add some more tasks or remove some tasks automatically for this auto scaling. So, if you want, like, you can even use that for unpredictable workloads. If your workload is predictable, so then you can simply define how many desired tasks you required. Okay, so let's scroll down and create. Now, we are going to get a new service here. Also, our load balancer is going to get a new listener. And make sure your load balancer security group, whatever the security group you are using here, that security group is opened with the required port number. So I already opened 8080 port number. So we should be good. Okay. So this is the Nginx and deployment status. 2 is in desired state, 2 is in progress. So we should able to view the changes here. Another listener created. If any issue with the port number, right? Observe these listeners on your load balancer, it will show not reachable. Observe the target group, a new target group created. If you observe two targets added, both health status is initial, we should get health status as healthy. If any communication problem is there, it will show, it will fail. So now this Nginx 1 also running as healthy. So now how to test this? So now 2 by 2 deployment completed. If you want to test, grab your DNS name, then colon 8080. Now you see here this DNS name working or pointing to port number 80. It is delivering one service and its tasks, and this is pointing to 8080 with another target group with the same load balancer. It is pointing to different target group. So that is how exactly you can create an ECS cluster and how to integrate that with load balancer and delivering multiple services from one single cluster. All right, I hope you find this video informative. So, and I assume you got a clarity on how this ECS and its Fargate mechanism works. Now, In next video, I'm going to explain how we are going to automate this process with the help of AWS CI/CD options. And also, I even going to make a video on very standard process. Currently, this ECS cluster and everything is running on default VPC, right? So generally, we don't run our workloads on default VPCs. So I'll make another video on how to perform that automation in our custom VPC with this ECS. So yeah, that is our coming two videos on this container series. All right, I hope you find this video informative. If you want more videos on any of the AWS technology, so please subscribe to this YouTube channel and please share so it might help someone who is trying to learn this containers mechanism. All right, thank you. See you again.